Hello everyone, today we are going to talk about some basic concepts. So we are going to begin chapter 2. So these are the concepts that you have already had in physics, but we're going to review them here. Scalar, the definition is a physical quantity that can be completely specified by its magnitude, which means that we only need one value to fully describe a scalar. A scalar could be length, which means that if I want to describe that, I just need to say 5 meter. Or the mass, let's say 10 kilogram. You just need one value of 10 times 5 seconds. And of course, you need to have a corresponding unit for it. A vector is a physical quantity that requires both a magnitude and a direction. So we need more than one value to fully describe a vector. Examples of vector could be force. So if I have a force, I can just call it 5 kilonewton because it's important what is the direction of that force. Is it towards positive x, negative x? So in 2D, in two-dimensional, I need two values, one the magnitude and one the angle. In 3D, I need more than one angle. The other examples of vectors could be velocity, could be position. So remember, position is different than length. You can say that a position is 5 meters towards positive x or negative y or at a specific angle. So a position is a vector. So now that we know what is a vector, we are gonna go over some of the vector operations. First one, multiplication and division by a scalar. So if you have a vector A, and if I want to find vector B, which is 2A, so I'm going to multiply by 2. 2 is a number, so I'm just going to multiply by a scalar. Just the magnitude changes, so B would be twice as A in the same direction. If that scalar value is negative, then the direction also changes. So C would be twice as large as A, but also in the opposite direction. So C would be in this direction. And if you notice, I usually use a small arrow on the top indicating that's a vector. So here also I've written if the scalar is negative, the direction changes as well. We can add vectors together, and we have two rules for adding vectors together. One is triangular rule, and the other one is parallelogram rule. And I'm going to go over both of them. So let's say we have a vector A here, and then we have a vector B here as well. The triangular rule is saying that put the vector one after each other. So I put the vector A here, put the vector B here. So that's my vector A, that's my vector B. And then the resultant vector, I connect it from the beginning of my first vector to the end of my second vector, and I call this R, the resultant vector. For the parallelogram rule, it's saying that we place both of them and I start both of them at the same point and then draw parallel to each other. Let me fix my vector B here. That's not vector B. So vector B is something like this. So for parallelogram rule, I draw a parallel line to both of these vectors. So parallel to this vector, to vector B here, I'm just going to try to draw a parallel line here. I'm writing on a screen, so it's not going to be completely straight. That would be the resultant vector. This would be the resultant vector, which is the same as this method. So in triangular rule, we place the first vector A, and then the second vector begins when the first vector ends. And then the resultant vector, R, which is A plus B, starts from the beginning of A toward the end of B. But in the parallelogram rule, we place vector A, and then after that vector B, and we place both of them at the same location. They begin at the same point, and then draw parallel lines to each, and when those parallel lines meet, that would be the end of our vector. That's how we can find the resultant vector by drawing. So R. In statics, we are interested in finding the resultant vectors, mainly for force. If we have multiple forces acting on our object, we want to see what would be the total force. And force is a vector, so we can't really add them together. If we have 10 Newton and 5 Newton, we can't say that the resultant would be 15. We need to use one of these rules to find. And this is just by drawing, and then we'll get into the equations, how to find a magnitude and the direction. What if we have multiple vectors? So that was for 2 vectors. What if we have 3 vectors or 4 vectors? So you could do the same thing. If you have, let's say I'm going to draw vector F1 here. That's force F1, F2, and F3. We show forces by F, denoting force. If I want to add them together, I have 2 methods. Either I can add 2 of them. I can call it R1, resultant 1, F1 and F2, and then add F3 to the resultant. So F3 would be R1 plus F3. Sorry, the total resultant would be R1 plus F3. Let me fix that. I'm going to call it R2, or the total resultant. So you just add them one by one. Or if you're using a triangular rule, you could just add them one after another one. You could add F1. This is my force F1. Then I will add F2. Then I will add F3. That would be my resultant. R. Here I named it R2 rather than adding individually. And this would be my R1 if I want to add them one by one. So that's the addition of multiple vectors. Again, we are dealing with vectors. We can't just add the values of the two. Vector subtraction is very similar to vector addition. So subtraction means instead of, if we have A, if we want to find vector C, which is A minus B, we can think of it as A plus negative B. So let's say our vector A is in this direction, and then we have our vector B. If I want to find vector C, which is A minus B, I will draw my vector A, and vector B would be the opposite direction. I'm going to find negative B. If this is B, negative B, B would be in this direction. So that would be my negative B. And then that would be the total vector C. So I'm going to draw it here in a cleaner way. That's A. That's negative B. That's negative B. So I'm adding A with negative B, and then I find my vector C. So subtraction is addition, is another form of addition. Now I'm going to talk about cosine law. That's the topic that is going to be part of your prereq quiz as well. So if you have a triangle, let's say I have a triangle with 3 edges, I'm going to call them A, B, and C. So the angle across A, I'm going to call it alpha, this angle beta, and then this angle gamma. And this is just a general triangle. It's not a right triangle, it's not an isosceles triangle, equilateral. It's just a general triangle. It works for any type of triangle. If I want to find the magnitude of C, if I have the magnitude of A, B, and the angle in between, I can find C. So C would be A squared plus B squared minus 2 times A times B cosine of the angle in between. So I can find the value for C. And the triangle does not have to be a right triangle. If it is a right triangle, we can use another simpler rule, which is a Pythagorean rule. So that one, let's say we have a right triangle, to see if what we get if we use cosine rule and the angle in between, which is 90, and I want to find c. So a squared, okay, a squared, I have a squared here, plus b squared minus 2 times ab cosine of the angle in between. Cosine of 90, what is cosine of 90? Is 0. So you can see that this one will reduce to Pythagorean theorem. But cosine law is the more general rule. And then we can have the sine law, which is a over sine alpha, the opposite angle, b over the sine of the opposite angle, which is beta, equals c over the sine of the opposite angle, which is gamma. So we have two equations here. I've just written it all together. So you can use either of these. Sometimes if you have a, you have b, you have alpha, you want to find beta, you can use this component of it and find the missing angle. So when you're forming your triangle to find the resultant force or resultant vector, you can use cosine law, sine law to find the corresponding angle or the missing magnitude. The other basic concept that we're going to talk about is a component of a force. So a force has two components. Let's say, again, we are starting everything with 2D and then move to 3D. If I have x and y, if I have force F here, if I have this angle, this has two components. One in x direction, one in y direction. I call this component fx. And this component would be f cosine theta. And then the other component would be in y, would be f sine theta. So if you have the angle, you can find each component. If I'm going to use this angle, then the fx would be f sine alpha and fy would be f cosine alpha.